Should be recording now. Great. So I'm going to begin right now. So, welcome, everyone that is here for this H2 math revision package. So I know some of you might be thinking like, how come it's a different person? It's not the other female tutor. So actually, there is a little bit of a change moving on. So I will be actually taking over H2 math and the teachings of the H2 math and all of the resource, giving out the resources and everything. So for those that don't know who am I, or you didn't come over from the O-level side of OVERMUGGED, so let me first introduce myself first. And then after that, we'll kickstart with the revision session. So first and foremost, my name is Kaiwen, and I've been teaching for about 4 to 5 years. This is actually my 5th year of teaching. And primarily for me, I teach majority is group classes and also crash courses. So for the past 4 to 5 years, actually past 2 years, I've been teaching for OVERMUGGED with their crash courses and group tuitions. And I specialize primarily in O levels only. And as of 2023 or next year moving forward, I will actually be teaching H2 math and also some of the JC stuff as well. Reasons because I do want to venture out into the JC curriculum, and also these are also things in my ballpark that I already know, and I'm just here to share my knowledge with everyone. So I've taught about 150 plus to about 200 students for the past 1 to 2 years. So I've interacted with quite a large number of people. So yeah, I do know how to handle myself, and I hope for today, you guys will be able to learn something from me to help you guys with your promo exams, or for those that are in J2, then you'll be heading on for your A-levels. Now, I might just misspeak sometimes and accidentally say Sec 4 and or secondary school. Okay, I do apologize for that. I'm still trying to get used to the whole transitioning on into A-level side. Okay. So these are actually the subjects that I'll be teaching on next year. So for the A-level side, particularly, I'll be doing H1, H2 math. And I will also, if there's a demand, I will do further math as well, as I think the further math syllabus is pretty beautiful, pretty nice. Same thing for the H2 math syllabus. So you can see why I like math in like the next 5 seconds. So the reason why I really, really love math a lot is because currently right now, I'm a university student and I'm in my year 4 this year, and I'm studying mathematics. So whatever I'm studying in like uni is actually whatever you are learning now in your J1 or J2 courses is actually what I have learned in my year 1 and year 2 courses. And also, of course, I came from a JC background, so I did cover all of these syllabus before. I did do all of these revision before as well. So as I was crafting the notes and everything, I did refer to my old JC materials, and also, of course, some other materials that I found along the way. So that's how I crafted this set of notes for everyone. So I'm actually doing pure mathematics. It's a little bit different from the JC's definition of pure mathematics. So the JC definition of pure math includes like vectors, sequences and series and all these kind of things. But in the pure math world out there, it's actually a little bit different. I deal with topology, and some of the geometrical stuff like surfaces. You need to know what all the different kind of theorems with regards to surfaces, all the differential geometry, algebraic topology. These are the modules that I love to take in university. And yeah, I'm kind of a math geek, so I really, really love math. And yeah, I'm just here to share my knowledge with everyone. Okay. So just to share a little bit of my testimonials and my track records as well for my own O-level students. And I do teach like 1 to 2 very rare cases of A-levels for like students that want to continue on with me one-to-one, then I do take them on. But currently right now, because my schedule is a little bit packed, so I cannot take one-to-one students anymore. So I primarily focus on O-levels. And I'm moving on into finding more A-level students. So I will say that 95% of my students all score about A and Bs for the O-levels or N-levels respectively. And I think this is pretty impressive for a large number of people. This track record I think is pretty good. Okay, I just want to shout out some of my students as well. I'm not going to mention their names, but I got students that jump from like F9 to A2 within 2 months. These are students that come to me from the crash course and then all of a sudden just shoot out and get A2 for exams. Okay, these are the people that work really, really hard is entirely doable. I do understand that the J2 syllabus or the H2 math syllabus is a little bit demanding, especially if, let's say, your secondary school math is not the strongest in the world. Of course, I have my own advice as to how I studied for my own J2 math and everything. Yeah. And another thing is that I'm also very, very proud to say that 100% of my students, right, actually get the desired grades that they want. So I got students that come to me and tell me that they want to get, or maybe they're just aiming to go to poly and they want a simple B3 for the math. They don't want A, they want B3. Yeah. And they in the end managed to get the B3 that they are actually aiming for. So what I can guarantee is that I will guide you along all the way towards wherever you want to go. But of course, the path definitely is on yourself. You need to work hard, and especially for H2 math, it's a subject that you definitely need to work hard on your own because there's a lot of grinding to do, there's a lot of practices that you need to do. So just take note as well, there will be a little giveaway at the very end. So this set of curated notes that you'll be getting, if you do win this little giveaway, will actually be from the previous tutor. I'm currently in the process of writing my own version of the notes, but that one will take a while to come out, not so soon. So you will get the older tutor's version of the notes for free. And how we're going to be doing it, now I'm going to assume that some of you have actually followed OVERMUGGED through this whole revision program, and a lot of tutors are doing Kahoot. But unfortunately for me, I don't really like Kahoot. I don't think Kahoot is a math thing. So I've come up with another way to do it. So basically for me, my style is very simple. I'll just flash a question on the screen. The fastest person to solve it, you give me the answer correct, I'll send you a copy of the notes. So that's how it will work for later. Very, very simple thing. So let's talk a little bit about the syllabus as a whole. So I think this is something that everyone is very accustomed to already, and you already know that, okay, a majority of you will have already covered about, I would say, 60% to 70% of the syllabus. Compared to the O-levels, of course, this is a very, very big jump. There's a lot of content, and I would dare to say that the subject is not as easy as O-levels. To me, O-levels, A-math, E-math is like a walk in the park. It's like some of the easiest things in the whole entire world. But I would say that JC math is a little bit different. There are topics in there that are a little bit more scary, which I completely agree. Okay, and if you have ever heard me teach before, I will always say things that are very easy. I rarely say things that are very difficult. But this is there are a few topics here that I would say personally they are not easy to score well. So for today, what I will be specifically doing is actually the calculus topics. So it's just those 4 topics down there. I will be going into detail on all of the calculus stuff here, and I will also be going through some little worked examples as and when if I have time throughout this whole entire session. I prepared some questions along the way, so if I have the time, I will definitely do them. And I think the notes are actually suffice of all the content that you need to know for these 4 chapters. So the split in the syllabus. So if you guys, I'm going to assume that the majority of you are in J1 this year, and maybe just 1 or 2 J2 students that are maybe preparing for your A-levels now. So the remaining topics at the bottom, those are your J2 topics. Excuse me. So complex numbers, some schools do cover it in J1, and also all of the statistics topics in J2. These topics they will teach very, very, very fast because these are not very difficult things. Complex numbers may be a little bit tough, but the rest are actually pretty simple stuff that can be done within 4 to 5 months, very, very quickly. And in my personal opinion, these are some of the more difficult topics of the syllabus. Now, of course, if I didn't highlight your own personal grievance with the topic, that doesn't mean that I don't agree with you that you feel that the topic is hard. Everyone has his own weaknesses. For me personally, when I took JC Math, my weakness was vectors. And because during my JC time, when I was learning vectors, I wasn't paying a lot of attention. So I'll be very honest. Okay, I wasn't paying a lot of attention. So this topic just flew by me very, very quickly. And I struggled very heavily with this topic in JC. But then when I hit into uni, my year 1, Sem 1 module was vectors. And it's not in 3-dimensional geometry, it's in n-dimensional geometry. So it became a lot more difficult. And I realized that, okay, The GC factors is not that difficult, but I do agree that some people might have some problems with it. Complex numbers is definitely a new stepping stone for a lot because you have never dealt with the letter I before, and also the variables that come with it, like the polar form, Euler's equation, and all that kind of stuff. Integration. So if let's say your O-level integration is not the strongest in the world, when you come into calculus for integration, there's a chance you might struggle because of the intensity of this chapter, especially now because there is like the volume stuff, the area stuff, and there's so many other formulas that you need to know compared to your previous round. And I've also highlighted probability. It's a bit strange, I know why. The probability that I'm talking about is actually the P&C topic, which is permutations and combinations. That topic is pretty monster. It's not the easiest thing in the world. In my personal opinion, that is one of the toughest statistics topics in this whole syllabus. Okay. So the structure of the revision session. So what I'm going to do right now is pretty simple. If you have tuned into my O-level sessions before, I'm going to do the exact same thing. I'm going to be first summarizing whatever I've done with this set of notes here. I'll guide you through some of the thinking processes, common mistakes that many people make, and then I will also go through questions. And I do know some of the sections where some students will struggle very, very heavily with. So I'll focus my time there on those sections. And then also, if I have time, I will look into questions. If in the unfortunate situation, I really don't, then what I will do is that I will upload these questions onto the folder later you will see, and then the solutions will also be provided. So bear with me as I'm just taking over this subject for the past 1 month. So I've been trying to rush everything as fast as I can. So same thing for resources, questions, and everything. It does take time, and I'm also schooling at the same time. So I hope there's some kind of understanding that I'm doing things at the fastest pace that I can do it. So without further ado, let's officially begin. So this is another link for the notes if anyone needs, and then I will just officially kickstart the whole session. If anyone has any questions while I'm going through the topic, feel free to just type it into the chat. I will respond. So as I see the question, if let's say it's a question that I can answer on the spot, I will definitely answer. If let's say it's something that I've already covered, then I will end the topic first, then I will answer them. So just before I carry on, are there any questions for me? Okay, I'm going to assume no. With that, let's begin. So this is the revision package that everyone should see. And you should see on the cover page, there is a picture of a colorful globe down there. So this will tell you that this is the free notes of the revision package. And let's skip the promotional materials of the next 3 pages. Hang on. So I'm going to skip that later. I'll come back to that. And I'm going to talk a little bit about this section here. Oh, also another thing, sorry, I forgot to mention. So if anyone wants to message me or ask me questions in the chat, right, if possible, I know some of you are very shy, so I totally understand. But if possible, send your message to everyone so that if anyone can answer the question, it'll make my life easier. But make sure when you're answering the question, you get it right lah, and you know your stuff lah. Okay, because if you don't, then I'll come after you. So okay. If possible, just post the question to everyone. Thank you. So there's a little QR code here as well that is shown on the screen, and it's also in your notes as well. Let me explain what this QR code does. If you were to access this QR code right now, it's actually empty. So there's actually nothing inside. Because what I'm doing is that I'm going to be compiling my own versions of the free notes, the chapter summaries, and also be compiling some questions for all the different chapters as the months go on. I don't think you'll be ready by your own promo exams or what, because I cannot rush it out so fast. But by next year, most likely this folder will have a lot of stuff inside. And I will also be dropping them into the A-level channel as and when I can. It's the same thing for O-levels. I do that for the O-levels as well. I compile some questions, I'll post and then send out the solutions as well. I will do the same thing for the A's, but I'll do them, of course, at my own comfortable pace. Okay, just to share about this particular link down here. Okay, so without further ado, let's officially begin. Sorry for talking so much. Okay, let's begin. If you're viewing this on a computer, actually all of these chapters are hyperlinked, so you can jump around to the different pages that you need. And let's officially begin with differentiation. So to start off differentiation, I've actually split up differentiation into two sections as how every school will have taught it. They will teach you the techniques first, then you will jump into the applications of differentiation. This particular chapter here is very, very similar to whatever you have already covered in secondary school. So there are some things that are a little bit different, and I believe majority of you would already know, which is your implicit differentiation, your parametric differentiation, your graphical interpretations of your first derivative graphs, and the rest are actually the same. These are the main three things that are a little bit different within the A-level syllabus. So for these sections, I will slow down a little bit. Things that are done within the O-level syllabus, I will go a little bit faster. Sorry, inverse triple functions as well. Forgot to write that. So these are the four things that I will touch a little bit on now as we move on. So the first section here is basically all the rules that we have all covered before in secondary school. And one thing about the difference between O levels and A levels is that we all need to be very accustomed to set notations and all these like Z plus and everything. Because as you move on, all of these symbols will be used a lot. Like for example, no one writes real numbers as real numbers anymore. We will use the set notation R symbol. Same thing for this. To denote integer, positive integer, I will just use all of these symbols already. Same thing for complex numbers, same thing for rational numbers, irrational numbers, and whatnot. So this one must get used to it because this is how the subject works. So first and foremost, we talk about the basics of like the chain rule and power bring down power minus one. Differentiation is something that never changes between O levels and A levels. And that's the beauty of mathematics. Whenever you learn at different stages in your life, everything still remains the same. It's not like your chemistry. In secondary school, you learn all your dot and cross diagram. Then you go into JC, you learn your other, I forgot what's the name of that thing, but it's like all your orbitals and all that kind of stuff. Learn something completely different. For math, it's exactly the same. You learn in secondary school, power bring down power minus one. In JC, it's also power bring down power minus one. So this one is really just go back into your secondary school and really just get all of these basics down first. If you cannot even do your basics differentiation, you can forget about doing A-level differentiation now. Next is the exponential functions. So there's three that we have learned in the O levels, which is exponential, the natural logarithms, and also the triple functions. These three are things that we have already covered before, but the main ones that I would like to focus on will be the last ones. This is the general form, where whenever we want to differentiate an exponential function, we're going to differentiate the power first and then bring it down. That's how it works for exponential differentiation. For logarithm differentiation, remember that if you're going to differentiate a logarithm term, okay, the result is going to be the differentiation of whatever is we are going to learn over the original thing. That is how we deal with logarithm differentiation. In the O levels, just want to stress something. In the O levels, whenever we write all of this, we usually just write ln ln x and the ln of ax plus b using curved brackets, not really with the modular sign. At the A levels, this is a little bit different. You must put the modular sign to define to people that you are strictly looking for x values that are positive, as we cannot learn negative numbers. So this is important. Next is the differentiation of the triple functions. Now for triple function differentiation, usually for the O levels, we are only tested on maximum going to be the rule number 2 of every row. We rarely see anything that does with squares or cubes or anything. If you want to see those kind of questions, you will need to go into prelim papers. O levels rarely test this, but at the A's, these are things that are very common, must know how to deal with them. It's just basic chain rule. So it's just power bring down, power minus 1. And you can get your answer. So this one I'm just going to breeze past because it's things that we've already learned before. Now we go into the actual A-level stuff, okay, which is the rules of differentiation for A-levels. We're going to start off with the reciprocal trigonomic functions, which is your cosecant, cotangent, and your secant. So these are just formulas that you need to memorize. Unfortunately, these are not given to you in your MF 26, but I believe the integrals are given to you. Let's just check. I have the MF 26 here. So let's see. Okay. Okay, maybe not given. Yeah, so these are actually not given. Only secant and cosecant is actually given to you. Cotangent is not. So these are things you need to memorize. I might say MF 15 as well, because when I took GC, it was MF 15. If I accidentally say it wrongly, I apologize as well. So just take note that differentiation, the rules that they give you will be your cosecants, your secants, and also your inverse triple functions. Within my notes, I just want to point something out now. So as you can see here, I wrote it as CSC. This is actually cosecant. It's just that because I'm using a coding software to do these notes, I don't actually have cosecant as a tool. I only have CSC, which is the official cosecant now. So if you do see this CSC, just take note that it's cosecant. Okay, apologies for that. So this is purely memory work, nothing too much to say, just need to memorize, especially for cotangent as it's not given. And the inverse triple functions here, the base x and also the ones with the fx functions must know how to use. They're all given to you. The extended versions are not given to you, so you just need to know how to apply. And just remember that your numerator is always going to be f prime of x, which is the differentiation of whatever you're going to like trigo by lah. Okay. All of these conditions as well, these are also given to you in your MF 26, and you need to take note that these are the conditions for your variables, for your x and your fx as well. Take note that you cannot violate these rules, or else you cannot solve your question. Next, we go into logarithm differentiation. For these logarithmic functions, some of you may not have actually seen it before, but actually don't need to worry, because all of these can actually be done using implicit differentiation. I've just written it out as a set of rules, as these are some very popular formulas that we can actually just use if you do know them straight away. We're going to talk about the first main thing, okay, which is implicit differentiation. So the process of implicit differentiation is basically when you have like xy and you want to differentiate xy. The problem now is that, let's say if you're differentiating with respect to x, your y is going to have a very big problem. How do we deal with it? Is we're going to deal with it using implicit differentiation. So I'm going to, there's some formulas that I've written here. So what happens is when we are differentiating with respect to, let's say, x, and you have a y to the power of something, what we're going to do is that we're just going to very simply differentiate. The only difference is that we're just going to put a dy dx in front of whatever we have differentiated. And then from there, we can just proceed on with the question. What's the reason why we need to do this? Is because we need to take into account that dy dx. And as we go on with the question, you will need to factorize all of your dy dx to indeed solve for dy dx. So just take note that this is a very important concept, and for majority of your questions now, if like your maxima, minima, or your connected rate of change questions, will all be using implicit differentiation. And also in your subsequent chapters, everything requires implicit differentiation. Okay, logarithm differentiation. So this is an example of what I mean by something that you can use implicit differentiation to work out logarithm differentiation. So there's an example down here of a function y equals to x to the power of x. And a method that we use, right, is to first go and ln both sides first. And then we can differentiate. Because we know we can differentiate ln y, but remember, we're differentiating with respect to x. So if you're going to have a y term, you must remember to put dy dx. And then you just need to factorize, make dy dx a subject, okay, and then you just solve the question. One very important thing you need to do as well, especially if you're doing implicit differentiation, you need to remember that your result of your dy dx, every single thing must be in terms of x. You cannot have a y. So you must remember to re-substitute back this y, or else you will get the question wrong. So just be very, very careful about this. Next will be higher orders of derivatives. So this is talking about your d2y dx squared. In the O levels, we have dealt with second derivative, where we use the second derivative for our test to test whether it's a point going to be like stationary, the nature of a stationary point, using the second derivative. But just take note that we can actually move on even further, and I believe we'll be doing that in Maclaurin series. So we need to know all of our d3y, d4y, d5y. It's basically just redifferentiating over and over and over again. I want to point out a very common mistake that a lot of students like to make. So I'm just going to write it here. So dy over dx, whole thing squared, is not the same thing as d2y over dx squared. This is a very important thing because a lot of people think that these two are the same thing, which is not true. The one on the left is basically just taking your derivative and you're squaring the function. But for your d2y dx squared, it is redifferentiating things one more time. So I'll give you a very simple example. I'm just going to craft a very quick example here. So y is equals to maybe, let's say, sine x. So if we differentiate, we get dy over dx, this is the cosine of x. And if we d2y over dx squared, negative sine x. So if we were to plug in here, this is cosine square x, and this is actually negative sine x. So this will tell you that these two are actually very different things. So please do not confuse yourself with them. It's the same thing when you're dealing with your Maclaurin series or your DE chapter at the very end. Please do not make this careless mistake of thinking that dy dx holding squared is the same thing as d2y over dx squared. It is wrong. So just be careful. Next, we're going to move on. Oh, there's one more thing. Sorry, just forgot to mention. So this is a little amateur mistake that some people have made before. Just want to stress something now. Okay, this one. So if let's say you see a function that looks like this, y equals to the ln of x holding squared. Some people, okay, they will think that this thing here, you can actually write it as y equals to 2 ln x. Is this true? No, this is wrong. Okay, this is not possible. As the reason why is because this 2 up here is actually only is powered to the entire function, not just the x itself. So if we were to differentiate this thing here, need to be a bit careful. So dy over dx, power bring down, power minus 1, multiplied by the derivative of the power. So the answer should be 2 over x, ln of x. Not just 2 over x, and that is wrong. So this is another one that is pretty common mistake that I've seen so far. Next, we're going to go into parametric differentiation. So under the graphing chapter in your, I think like maybe your opening first 2 chapters in your syllabus, under graphing techniques, you have learned something about parametric equations, where you will have equations in terms of t, and one side like have an x, one side will have a y. So parametric differentiation is basically when you're going to differentiate both of these equations, and then what you can do is to use chain rule to combine both equations together. Parametric differentiation usually is some of the easiest kind of questions, as it's pretty straightforward. But just one little advice at the bottom down there is that we try our best not to go and combine both parametric equations into one first, and then we go and differentiate. The reason is because sometimes when you go and do the transformation and the squeezing, right, it might make things a lot more difficult. And the thing that it comes out might be very tough to actually differentiate. So this is an advice to go against it. Do not do that. We just apply whatever we know, we differentiate them separately, and then we apply our chain rule to find the derivative. Usually, if we do it this way, it will be a lot simpler as compared to combining the equations together. Next is the applications. So I'm going to very quickly run through the applications. The one I will slow down on will be the things that are new, which is the concavity part, and also the graph, which I think is the last parts of this chapter. And I will actually want to do one example question of a graphing question, because I want to show everyone a method that I've learned to actually help you to sketch your differentiation graph. So the first concept here is about increasing and decreasing functions. So for increasing and decreasing functions, we need to know what are the differences between them. This is the same thing for O's. The increasing function is basically when your derivative is strictly positive, or your derivative is strictly positive or strictly negative. Increasing function is greater than 0. Decreasing functions are less than 0. So if the question asks you to prove that a function is strictly positive, if the question asks you to prove that this function is strictly increasing or this function is strictly decreasing, you need to differentiate the equation, and then you just show that the dy dx is indeed going to be less than 0 or greater than 0. Next, concavity. Concavity is something new. It's not in the O's. So concavity is a little bit different. This is actually more on the analysis of your d2y dx squared, and we are actually going to be analyzing what is happening to our dy dx. So for normal increasing and decreasing function questions, we are analyzing what is happening to the curve using the y. But for now, what we're going to be analyzing is actually the dy dx, what is happening to the respective gradient. And if your gradient is increasing, is considered as a concaving upwards. If it's a decreasing graph, then it's concaving downwards. So this is just memory work, nothing difficult here. Stationary point. So stationary points is something that we have all covered before. Okay, just to recap, stationary points means that dy dx is equals to 0, and we have natures that we need to know. So we have local maximum, local minimum, points of inflection. Some of you, if let's say your school will go through, you will know something about global maximum, and you will also know global minimum. If you have never encountered these two words before, then forget about it. Okay, but it's basically about the same thing, just maybe a little bit different now. Okay, but I don't think it's in the syllabus. So we just talk about local max, local min, and inflection, which is basically the same thing. If you have a local maximum point, how do you prove that a function has a local maximum point? By using your first derivative test or your second derivative test. So the tests are here. The first derivative test, remember that this test here is a 100% success rate. And for the second derivative test is actually a 66% chance of success. I'll explain why. So for the first derivative test, we can tell whether it's a point going to be local max, local min, or inflection, just by looking at the shape of the graph that you actually got. This one we all know, and we always test using values that are plus minus 0.01 of the graph. So for example, if let's say your point is like x equals to 2, we will test 1.99 and also 2.01. If you want to be extra kiasu, then of course, by all means, 1.999 and 2.001 also can. Okay, but the basic idea is that you just need to go very, very, very close to the maximum point or the minimum point and figure out what is the shape like going to be around that point. Now, another way that you can actually tell whether is this a stationary point or not is to use your GC. And you can actually key in the graph into your GC, and you can actually see what kind of plot is it going to be, and then you can answer your question. But you must remember that if the question asks you to show, you cannot take a photo of your GC and then give it to the examiner. Cannot. It's either you draw the graph, or you prove it graphically, or you prove it using the derivative test. Of course, the fastest is definitely using the derivative test. Last one. Okay, for the second derivative test, remember that for this one here, greater than 0 means it's a minimum point. Less than 0 means that this is a maximum point. If you realize this actually links to concavity as well. Okay, greater than 0 means that you're concaving upwards, so there's a minimum point. Less than 0 means that you're concaving downwards, so there is a maximum point. And the last one is your d2y dx squared. When it's equals to 0, remember that this is an inconclusive test. So if, let's say, in the exams, you have done your question, and in the end you got a, your d2y dx squared is equals to 0, when you have substituted your x value in, you know that you have messed up some, you know that the point cannot be determined using the second derivative test. So you need to redo and do your first test. Is it necessary to cancel your working? No, just leave it there. Just write that it is inconclusive and just show the whole world that you made a mistake by choosing the wrong test. That's all. Some people, of course, prefer to just straight away use the first test. For me personally, I like to look at the equation first. So if you are very, very good at your differentiation and you can differentiate things in your head just on the fly, and you can work out your second derivative test in your head straight away, and you know that when you sub in the values in, it's confirmed 0, then just do the first test. And of course, we need to look at the difficulty of the equation. If the equation is so complex, not complex as in complex, but difficult, if it's very, very, very difficult, then of course, first test is a lot faster than the second test. Okay. Next, we're going to talk about okay, I'm going to jump this part first. So I'm going to skip the graphs. I will come back to it in a while. Let's go into the gradient tangent normal first, which is the next page. So under the gradient tangent normal section, this is very, very simple stuff. Remember that gradients can be read off using your y equals to mx plus c line. And the O-level definition of dy dx is basically gradient of a line. It's not the official definition. I hope most of you already know that dy dx does not mean gradient of a line. It means something else. Okay, but we all know dy dx is considered as the gradient of a line. To deal with your tangents and your normals, remember that normal is always perpendicular to your tangent, and we're going to reuse the fact that when two lines are perpendicular, the gradients products are going to be -1, and you get your equations down there. Okay, this is very simple stuff. I don't want to hop too much time on it. Next one will be maxima minima. So for maxima minima questions, it's very, very obvious when there are going to be maxima minima questions. If you have been doing enough practices, you should start to realize a trend that all maxima minima or majority of maxima minima questions, they will give you a diagram. And usually the diagram will be quite funky one. And then they will ask you to figure out some volume, some random volume or some random shape, something like. Then they will ask you to figure out whether is it maximum or minimum. So those kind of questions are very distinctive as to when to use the maxima minima concept. The difficult part is usually the first part, which is the showing. So in your exams, if let's say you cannot show, unfortunately, then just leave the part blank. It's fine. Then just carry on with life and move on. Unless you face those kind of questions where the question asks you to find what's the volume, then differentiate the volume, then no choice. The whole question will die. Last one is connected rate of change. So this one is where you deal with questions that deal with time. Very, very distinctive kind of questions as well. Whenever you see rates, you see the elements of time. These are very obvious that these are rate of change questions. Some things that you need to take note of, remember decreasing stuff. So for example, if you let's say you have a cup and you put a hole in your cup and you have water leaking out of the cup, then this is going to be a decreasing rate of change. Okay, the value is going to be negative. Take note now, it must be negative when you're calculating your rate of change. Or let's say if you're pouring water out of a container, that kind of thing. These are negative values. But if let's say you're pouring water into the container, then it's a bit different. Those are positive stuff. So you must separate between the two, positive and negative. If the question asks you for what is the rate of change or rate of decrease or something, or rate of change is increasing or what, you must remember what the sign. Okay, you cannot confuse yourself. If the question says rate of decrease and the value calculated is a negative value, then of course you do need to leave the positive answer. Okay? And that's basically it. So I'm going to go back into the graphing section now. And I believe this is one of the major big problems that a lot of people have, especially if you're not good with this kind of drawing graph question. So for me, I have a very specific systematic way of doing these kind of questions, which is to deal with the asymptotes first, then you deal with your general shape, then you deal with your stationary point. I call this method pseudo-graphing. So I don't know whether if any of your schools could teach you this method before. So I'm just going to first go through all the different concepts. Then I'll very, very quickly just demonstrate it with a question that I have prepared right here. So we're going to start off with the asymptotes first. So basically how I wrote it is that if your mean y equals to fx function has something, what is going to happen to your differentiation graph? So for example, for vertical asymptotes, you need to remember that for your derivative, it's going to be also a vertical asymptote. So for me, whenever I see vertical asymptotes in your question, I will automatically just put back the vertical asymptotes because these are things that never change. Next will be your horizontal asymptotes. So for example, if you see a question, your graph is leading like there's an asymptote at y equals to -2. Then you know that your graph is going to have a horizontal asymptote at y equals to 0. And the reason is provided there. If your function has an oblique asymptote, so just to recap, oblique asymptote means that your asymptote is a line, is a slanted line of the form y equals to mx plus c. Your gradient function will tend towards the gradient of the line. So if let's say your oblique function is, let's say y equals to 2x, okay, this will tell you that your graph, right, it will tend towards the asymptote at y equals to 2, okay? Next is about the general shape. So how does the shape usually look like for a derivative graph? So for this, right, there are a few cases here. If the gradient of your y equals to fx is positive, and then it will be above the axis, because that is what we mean above the axis of the dy dx function. If it's negative, that will be below the graph. If it's a concaving upwards graph, it means that your f prime x is increasing. If it's a concaving down, it will be decreasing. Okay, it's just basic concepts from your concavity and your increasing, decreasing functions. Last one is your stationary points. So there are two types of stationary points that we need to remember, maximum and minimum. So if you have a maximum or minimum point, those are automatically going to be your axial intercepts. So those are things I'll label straight away. Inflection. Whenever you see a point of inflection, those are turning points. So as long as you can remember this whole list of what everything does, the graph becomes infinitely easier to draw. So I'm going to right now, very, very, very quickly, I'm just going to scroll right here to the blank side here. I'm just going to sketch out a very simple example of a question, and we're going to draw the derivative of the graph. So y x. Now, of course, if let's say during the exams, you see the graph, right? And the question gives you the equation of the graph. They never say y equals to fx. And the question asks you to plot the derivative. Then like that, you can just differentiate the equation, plot on your GC and drop. But I'm pretty sure 99% of the time it's not the case lah, because like that, it'll be way too easy of a question already. Okay, so we have the xy axis like this. I have a few vertical asymptotes, so I'm just going to very roughly just draw. I apologize for the horrendous drawing in a while. X equals to 2. X equals to -2. So I'm going to extend down a bit like this. It's going to intersect at -2. Yeah, so I'm going to label that. And there's actually a asymptote here as well. Okay, so this is y equals to -2. And it's going to cut through. So just take note of that. Okay, and I have some more intersections. Maybe let's call this -1, 0, -2. So this is the function. And let me check if I got anything else. No. So the question is asking you to sketch what is the derivative of this function here. So let's just do it step by step. I will just go down my checklist here. I will start with the asymptotes, then the general shape, then the stationary points. So first thing is that vertical asymptotes means, okay, I'll copy my vertical asymptotes. So I'm going to copy my axis. Okay, so Y, X. And I'm going to label all of the very, very important points. So this is what I mean by pseudographing. When you go into your graph, you go and figure out where are all the important junctions of your question. So example will be here, x equals to -2, as this is your asymptote. You have the axis intercept here. This is also very important. And also the other point here. When it crosses the x-axis, this is not very important. So this one we don't care for now. Okay, remember the concept says that for vertical asymptotes, we just draw the asymptotes down as well. So there's an asymptote here. Okay, x equals to -2. X equals to +2. Next, we're going to deal with any horizontal asymptotes. So there's one there at y equals to -2. So this will tell you that your graph is going to be asymptotical to the y-axis. X-axis, sorry, it's going to be asymptotical to the x-axis. So just remember that there's a asymptote here. So I'm just going to write here asymptote. And for this graph here, there is no obliques, so we don't care. We move on into the general shape. Now we're going to look at what is happening to the gradients of the graph. So if we look at this section of the gradient here, we can see that the gradient, okay, is starting from, okay, remember, this is asymptote at y equals to -2. So the gradient is actually going to start from a negative value, and it's going to get even more negative and more negative and more negative. So this is going to be a negative graph. So this shape is going to be down. And it's going to be asymptote to the x-axis is because, remember, we are touching very, very close to the asymptote, but we are not going to hit 0 mark. So we're going to go very close, but then we're going to go down. And just nice, it follows the asymptote at y equals to 0. Next, observe here, positive gradient, positive gradient, positive gradient, and suddenly reaching 0. So this is a positive gradient section. So this is going to be from below and going to slant upwards like this. And repeat the same process there, going down. Okay, and then here. And then we know that this as well here, this is what we call it, the point of inflection. So point of inflection means that there's a turning point on the y-axis. So there's a turning point here. Label the turning point. And we're done. So this is a very simple example of a graph. They label everything that you need to know. We have the asymptote. Let's call this y equals to 0. 0, 0, graph drawn. Yes, very good. And this is how the whole graph actually looks like. This one must practice. So there are many different examples out there. You can take school papers or go and check your own school tutorials and lecture notes. There are many examples there. Okay. Very good. Okay. Any questions? Why does the whole graph become negative? Okay, good question. The whole graph is negative, right? It's because we are analyzing the gradients of the function. So if we look, right, okay, I explain again for this part. So first thing is that this portion here, this is asymptote. Okay, it is going very close to a horizontal line, but it's never ever touching. So if you understand the concepts of limits, okay, it's approaching very close to -infinity, but it will never ever reach 0. So the gradient is going to be starting from a negative value and going to go even more negative and more negative and more negative. And that's why it's going down. Okay. And it's the same thing for the top as well. Okay, it's basically the concept. It's the same thing for the pink part when I've explained. Okay, we are starting looking at the gradient values. We're looking at a positive gradient, okay, and we're going to get even smaller and smaller and smaller and smaller and smaller, and therefore it will look like this. Actually, if you guys know, this is actually the negative tangent graph, and your cotangent graph is actually like that. Yeah. It's just a simple example. I hope I answered your question. If I didn't, then afterwards you can ask again. Okay. Can we see an example with an oblique asymptote? Sure. Okay, do I have time? Okay, sure. Okay, I'll do one very, very quick one with an oblique asymptote. Very, very, very quick one. Okay, for example, just let's have another example put here. Okay. Y, X. Apologies for the horrendous drawing. Okay, but I'm trying my best. X equals to 2. Shoot. Okay, y equals to x. Okay, I'm going to draw the graph. So it's like that, like that. Okay, so imagine you have a graph that looks like this. I don't know whether can you see the red color lines on the screen. If you can't, then I'm so sorry. Yeah, it looks like this. This is the standard y equals to fx graph. I'm going to label the minimum point here. This is 3, 4. And this is 1, 0. And I think that's about it. Yes, that's about it. So we're going to repeat the same process now. So start off with vertical asymptotes first. So I'm just going to draw below. Vertical asymptotes at y equals to x equals to 2. So x equals to 2. Next, horizontal, don't have. Oblique have, okay. So the question says that y equals to f prime x tends to m. I believe there's I think a small typo here. Y equals to m. I think that's a bit better. So this should be y equals to m. It's a horizontal asymptote. Okay, sorry, not just m. Y equals to m. Sorry about that. So let's look at the gradient of this line. So y equals to x means that m equals to 1. So we're going to draw y equals to 1. Okay, so have a line. Okay, y equals to 1. This is your asymptote. And now we're going to check through the whole graph. Okay, so we're going to find where are all the we're going to check the stationary points first. So stationary points, there is a maximum point here. So this is a maximum point. And there's a minimum point here. So remember, maximum and minimum point means that it will turn into axial intercepts. So it will turn at axial intercepts at A. So this means where 1, 0 is going to be, okay, we use another color. So here, 1. And for the top one down there is 3, 4. So it's going to intersect at 3. So we're going to label here 3. So these are the junctions where it will cut the x-axis. And now let's analyze the graph. What's happening to the gradient? So we're going to go section by section. We look here, this portion down here, this is a positive gradient. Oh, sorry, this is negative gradient. This is a negative gradient, okay, and it's getting more and more and more negative, okay, until it reaches here. Okay, so it's going to go from here to here. Yep. And then after that, from here, it's going to shoot downwards. So we're going to follow down. Okay. And then for the top, this is from a positive gradient, okay, reaching 0 and then increasing. So from here, and this should be the answer. Okay, so if anyone needs me to go through this, I will save it for later, okay, because I don't have enough time. Okay. Now I'm going to move on to the next part, okay, which is the next chapter, Maclaurin series. So 3 more chapters to go. Maclaurin series. So Maclaurin series is, to be very honest, a very simple chapter, as there's nothing much lah. The beginning part is a prereq to binomial theorem. So binomial expansions in the O levels, where your n integers are your n's are positive integers. So that's the whole first page. So we need to know what are the binomial expansions, how to use the formula. It is also given to you in your MF 26. So just take note of it. Remember about the different stuff like independent term of x, you need to know that that's x power 0, and then your general term. So if you didn't know, the general term here, n choose r a to the power of n minus r b to the power of r, is actually hidden inside your form here. Okay, this is actually where your tr plus 1 actually is going to be. So in case you forget, the formula is actually just that. A few more things. Okay, remember that for some of the questions, right, we talk about the r is always a positive integer, but now take note that it is possible at the E levels that your r value turns to the r value must always be a positive integer, but your n value now at the A levels can be a fraction or can be a negative value. So that is for the next page. Okay, but just take note that the condition for r is that it always must be a positive integer. Whenever we are dealing with binomials of powers that are not given, or when let's say your n is no longer going to be a positive integer, we must use this formula here. This formula here is to help you to work out what are the different formulas for n choose 1, n choose 2, n choose 3. But just to show, so for example, n choose 1 is just n choose 2 is n minus 1 over 2, n choose 3 is n minus 1, n minus 2 over 3 factorial, or 6. So this one here is either you memorize the whole list or you just go and know how to use this formula. The formula is pretty self-explanatory and it's given to you, so don't need to worry too much. Next, we're going to talk about the binomial expansions that deal with, okay, so these symbols here, if you don't know what it means, the set of rational numbers excluding 0 and all positive integers. So it means that we are dealing with like fractions. Or we're dealing with like negative powers. That is when you can use them as well. Okay, this formula is given to you. It's not written as a binomial formula. It's actually under your Maclaurin expansions, but it's the same thing. Okay, all of the different like n choose 1 and choose 2 formulas are already shown inside down there for you. Take note as well that this is going to be an infinite expansion. For binomials, remember that it is a finite expansion. For this is an infinite expansion. And also, remember that whenever you are doing this kind of binomial expansions, you need to remember that a condition is that the in front number must be 1. It cannot be anything else. If let's say you have a 2 in front, or if you have like a x in front, you need to do some other stuff. And you must be careful. For binomials, right, you can have other numbers there, but for this particular expansion, when you're dealing with like power half or like dealing with something else, you need to remember to do that. So there are two different cases here for ascending powers of x and for descending powers of x. In the O levels, usually we don't care about the ascending powers and descending powers because it's automatically done for you. But for this, for A levels, you need to know. If the question is asking you for ascending powers of x and you see that your expansion down there, your inference is actually an A, not a 1. You need to factorize out that value. And the factorization is done this way. Okay, so it's a to the power of n, 1 plus x over a to the power of n. The one that a lot of people will forget is the power n up here. Okay, the number that is being put out must be powered as well as you're pulling it out from the bracket. Okay, take note that the validity of expansions is the same thing in your Maclaurin series. Validity of your binomial expansions is important. We usually look at this. Okay, the modulus of that value is less than 1 for all small values of x. For descending powers, okay, remember, if you're talking about ascending powers, it's always 1 plus something. And then we always make sure the a is in front, and then we pull out the term. But for descending powers of x, it's a little bit different. Okay, we always position the x to be in front first, and then we pull, such that the term will change. This will no longer be x over a, this will be a over x, and it's a little bit different. And take note that this is for large x as well, as we're going for descending powers of x. Take note that all of them got restrictions and all your validity stuff from your Maclaurin series is all the same right here in this chapter. Next, we talk about Maclaurin series. So for the Maclaurin series, okay, remember that this deals with differentiation, as this is where we do all the second derivative, third derivative, fourth derivative, and whatsoever. Most of the time for Maclaurin series questions, we will always see until max is going to be power 3, power 4, or third derivative, fourth derivative. That's the max. And remember that we're always evaluating at x equals to 0. Personally, I feel that Maclaurin series questions are giveaway, as it's most of the time just given to you in exams. So nothing too difficult for this. The steps to finding the Maclaurin series is given here. Okay, first thing is that we differentiate repeatedly first until where we need to stop. Substitute the value of x, and then you throw into your formula. And this formula is also given to you, so it shouldn't be too tough. Last one is the standard Maclaurin series. So these are expansions that fortunately you don't need to memorize. They are all given to you. So in case you need to use, you can use them. And the way to use is, for example, if the question asks you e to the power of x plus 1, and they ask you to expand, you're basically just replacing all of your this x plus 1, okay, with just an x. And then you just apply it into your formula. So it's just literally just application of formula. It's nothing difficult here. Okay. Of course, at the very back here, these are all ranges of validity. So just remember that these are important conditions that you need to state whenever you are writing out your Maclaurin series. Last one here, it will be small angle approximation. So approximation and this small angle is only done for sine, cosine, and tangent. And usually for questions, these are pretty brain dead questions. They are very, very simple. You're just basically applying formula. And the 3 are down there. It is not given to you, but it's very simple to memorize. Just remember that sine x is just x, tangent x is just x, and cosine is 1 minus x squared over 2. And also take note of a few things. This is a very important thing. Questions will state if the x is small or not. The questions must state to you that the x is sufficiently small. So then you can comfortably use this small angle approximation. And most of the time for the questions they will ask you to approximate, they will tell you that x is indeed going to be a very small value. Last one here, this is a very interesting thing. Okay, you're actually not allowed to assume that if you plus a constant towards your x, right, you cannot assume that this thing, the final result, is going to be small, unless the question says that k is indeed small. You need to be a bit careful. If let's say you're dealing with like x plus k, you need to use your compound angle formula first. So for example, if let's say, right, is sine of x plus k, what I will do first is to expand using my addition formula. So this is sine x cosine k plus cosine x sine k. And then we repeat the question. And that's basically it. So for Maclaurin series is pretty simple chapter. I don't really want to spend too much time on it. Does anyone have any questions on this? Okay. So I'm going to assume no, and we're going to move on into integration. So for integration, which is the next section, so this chapter, like I said in my opening, this chapter is not very easy because of the substitution and the by parts part. So the main thing, a lot of people struggle very heavily with integration at O levels, and yeah, they have a lot of problems with it because it's like not intuitive and everything. It's the same thing here. If you're not careful, this can bite you in the backside. So just be a bit careful. So first off, let's recap first all of the O-level rules for integration. So up there is the basic rules, power plus 1, divide by the brand new power. And this is how it will actually look like. Okay, of course, remember that this is a very important property. Product of constants and function, you can always pull out the constant, okay, of your integral, and then you will make your integration a lot simpler. Next, indefinite integrals of exponential functions. So if you're dealing with exponential functions, is for your differentiation, remember, is you're pulling the differentiation of the power and put it beside your exponential term. But for integration, you're dividing by the brand new by the differentiation of the power. So if it's me, I will just memorize this general case here. Next is the integrals for the trivial functions. Of course, we know now at the A levels, there are many, many more trivial functions. These are the basic ones. First, we start off slow. We start off with sine, cosine, and tangent. Okay, remember that differentiating or integrating sine, you get negative cosine. Integrating cosine, you get positive sine. Integrating secant square, you get tangent. Nothing difficult. The remaining 3 later will be discussed. Reciprocal functions. So at O levels, we don't teach integration of ln. So the way to do it is this. So f prime x over fx will just be ln the modulus. Now this is very important. So it is a fact that we need to write like that. The mod of the fx, because we need to justify that fx is indeed going to be strictly positive, as we cannot ln a negative value. Next, rules of integration. So for the rules of integration, some of the things that we need to take note of is we're going to for A levels part, we're going to extend, of course, the trivial parts, and we're going to go through tangent, cotangent, cosecant, and secant as well. And all of these are actually given to you in the formula sheet. Now, I just want to just a reminder again. This is cosecant. So all those with the asterisks means that they are in your MF26. So you don't need to memorize, but just take note that the function versions, right? These are important now. So for example, in order to integrate like this function here, you need to make sure that in front contains the f prime x, or else you cannot integrate. Next, I have a list here of all the different types of trivial functions that we can integrate at the A levels as well. And there are a lot of combinations down here. I believe I put down 3. So what happens when you're dealing with like sine squares, cosine squares, and tangent squares? We use our Pythagorean identities, and they are all here. They are given to you during your exams as well, so don't need to worry. Next is your integrals involving, let's say, your sine 2x, cosine 2x. How do you deal with it? We use the double angle formulas. It's the same thing for tangent x as well. Tangent something x, we always just use the double angle, and then we differentiate from we integrate from the cosine square. It'll be a lot simpler. Next is if you're dealing with like products. So for example, if you see questions with like sine 2x, cosine 2x multiplied together, or you see like sine 2x, sine 2x, sine 3x, that kind of thing, it's factor formula. The formulas are also given to you in exams, so you don't need to memorize. It's just application. Practice, you'll become very good at this. Next, the integration. So this is the other list of more complicated stuff. So I split it into 2 sections. So the first 2 up there is for your tangent inverse and your sine inverse. So just take note of the denominator. It's a bit different. X squared plus a squared is tangent inverse. The square root of a squared minus x squared is sine inverse. And then for the bottom 2, x squared minus a squared is the ln. And then for a squared minus x squared without the square root is also a ln. Okay, but the things within the modulus is different. And also all of these are given. Okay, so you're given the formula booklet in exams, so you don't need to worry too much about it. Next, we're going to talk about the more scary stuff, okay, which is the substitutions. So integration by substitution and then by parts. So for substitution, At the A levels, right, a very fortunate thing for everyone is that your substitutions are always given to you, and you will always be told what to do during the you'll always be told that this is going to be your substitution tool. And with this fact, it makes questions a lot simpler as it already is. So for example, we look at this example question here. We are given that u is equals to the root of x. We are going to use this as a substitution. For me, what I like to do is I will write these things here on the left-hand side or the right-hand side of my paper. And then I will apply them into my integration formula. So we're going to change all of the x's into the u's and change all of the dx into the du's. Just take note that all of the dx's must change. Okay, but one thing I want to say is this thing here. It's very illegal to write this. Dx is equals to 2u times du. This thing mathematically is not correct. So if you were to write that in exams, I don't know about some schools. Some schools are okay with it, but I'm pretty sure this is not very allowed. So just be a bit careful. If it's me, I will not show this lah. You can mentally know that this is a fact, but don't ever write it down because it's not mathematically accurate. Next, we're going to deal with the definite integrals. So this is a little bit different. For your definite integrals, you need to remember that your limits, your lower limit and your upper limit, you must change them to your corresponding new variable. So for example, if you're given everything with respect to u, you need to convert. If you don't, then you're going to be integrating in the wrong range and you're going to get the question wrong. This thing about the limits is something that a lot of people will forget. So just be careful. Okay, for example, if we're going for x equals to 0 to 4, using this example here, when we are changing it to, I used z. Sorry, I think I made a typo. Sorry, this is z. Sorry about that. So all the z's were changed into 1 and 3 respectively, and then we perform the integration. Now, sometimes when you're doing this substitution thing, when you substitute, you will realize that the numbers, the top and the bottom, actually don't match. Like for example, when you do it, you might get like 1 and then on top half. When you see things like this, right, you do need to flip the integral, and this is a very famous law. Okay, remember that. I'll write it for you. The way to flip this law, okay, is to take integral ab of f of x dx. Okay, is the negative of ab f of x dx. So in the event where you need to flip your limits from the bottom to the upper, or vice versa, then you take a minus sign on the outside, and then it will help you to flip your integral. Next is by parts. So I will say that the main problems with integration is this substitution and by parts. Most people have problems is by parts mainly. So for the by parts thing is a formula thing. So first and foremost, this formula must know not given, must memorize by heart, and you must know how to do. And I believe most schools will teach you to draw on the corner your U and V table. So whenever you are doing any questions, you will identify which is your U, which is your V, or in this case, which is your U and which is your dvdx. So when are situations where we use when we use integration by parts? Whenever we see it's a product of two functions. So as we all know, we do not have any product rule in integration. The only way we can solve this kind of product stuff is using integration by parts. And you must be very smart in the way of how to choose which function to be your U, which function to be your dvdx. And down here at the bottom, there's a list of the different types of questions. There's a very big words here, the LIATE. This is a way to memorize which one do you choose your U. And we're going to choose from left to right. So for example, if the question contains a logarithm term and an inverse triple function, we always choose U to be the logarithms and then the dvdx to be your inverse triple. Just follow the rule. If you have an L and an A, we choose the U to be the L and then the dvdx be A. There's a reason why. Is because we always try to make the things that are easier to integrate. Excuse me, sorry, the things that are easier to integrate, we let them integrate. Okay. The ones that are super difficult to integrate, we try to keep them at the very back. Okay, so that we try not to integrate them. We try to differentiate them instead. So there are 4 different cases down here. I'm not going to go through them in detail. You can read them on your own. Pretty self-explanatory. Actually, if you do enough by parts questions for A levels, it becomes very like mechanical, because all of them are pretty much the same thing. Okay. Next, we go into the applications of integration. So there are some applications of integrations that we need to know. The main ones will be the definite integrals, of course, your areas under the curve, and the last one is going to be your volume. So during my time during A levels, there was no volume, but yeah, it's not difficult, it's the same thing. So the first part will be the definite integral part, and you will be introduced to this theorem called the fundamental theorem of calculus. There's actually a part 1 and a part 2 of this theorem. For the A levels, we only need to know the part 2, okay, which is this, which is based in basic form, is just what a definite integral is. If you have an A to a B, you're just going to integrate, and you're going to take the capital FB minus FA, and you get your answer. Now, the GC is very powerful. You can actually use your GC to actually calculate your integrals if the question never say you need to leave in exact form. If the question just say evaluate this integral for me, you can just type in your GC. However, if the question says please leave it in exact form, or please use, they say by parts, or must use by substitution, then obviously you cannot use the GC, but you can check with the GC, of course. Just check whether your answer is indeed correct or not at the very end to know whether are you right or not. Next, definite integrals as a limits of the summation. So this concept down here is basically about how do you split up an area under the graph into many small rectangles, and what is its implication. So whenever you have something like this, right? Okay, what we will do is we are going to split this whole entire area into multiple rectangles, or you can just read out whatever is written here, and you're going to sum every single area, and you're going to get your summation. Okay, and then you will see the limits. Why is there a limit here? Is because we are going to assume that all of these areas of your rectangles are going to get even smaller and smaller and smaller and smaller and smaller, such that you're essentially just calculating the integral between A to B, and you get your answer. So we're going to talk about the different types of areas that we have that we know. This one is very similar to whatever you have learned in the O's, but maybe this one is a little bit more difficult, of course. If it's above the x-axis, then you're integrating between A to B, the value is positive. But if it's below the x-axis, remember that we are bounding by the x-axis. So very important, we need to know where is the boundary. For this case down here, the boundaries are going to be your x-axis. And if you know that your area is going to be underneath the x-axis, the value is going to be negative. So you need to put in a minus sign. It's either that or you put the mod. It's either one. Either one works, whichever your school teaches you. Next one here. So this one is with respect to the y-axis. So if you're integrating with respect to the y-axis, then if you're on the right-hand side, which is the positive side of the y-axis, the value will be positive. If you're on the left, then it will be a negative value. Now take note the difference between the previous two pages. The equations are different. For the previous page on page 35, that is y equals to fx. For this page down here, this is x equals to gy. Your equations is in terms of a different variable. So you must convert basically. So yeah, basically that, sorry. Next, we're going to talk about areas enclosed within two curves. So this concept down here, even it looks very chim, but it's actually very simple. We just take whichever graph is above, whichever graph is below, and we take the on top minus the bottom. We will get the answer. The main logic behind it is because when we are integrating between A to B for fx, we are calculating this whole entire thing. And we are doing the gx is basically this pink part here. I hope you can see the difference in the color. Okay, maybe cannot. Let me just change the pen. Yeah. So essentially what you're doing is you're finding the area of the purple part minus the area of the blue color part. So that's why we always say just take the upper curve minus the lower curve. It's the same thing as when you're dealing with like lines and curves. So for example, if you are dealing with like a curve like this, and you have a line. Okay, so for example, if the curve is like that, and the question is asking you to figure out what is this area. So what we do, we see that we first find what are the points of intersections between the line and the curve using simultaneous. And then after that, we take the curve, the line, sorry, minus the curve. Because the line will give you the area of the trapezium, the curve will give you the under part. And remember that we are always bounding by the x-axis. Okay. It's the same thing for the y, so same concept. Nothing changes here. Next, area under the curve for parametric. So for parametric equations, actually this is pretty simple. Number one, we try not, okay, not try not, but we definitely do not go and convert both of them into the Cartesian form first, because that will take a lot of effort. So we do not do that. What we do is we are going to just apply the formula that we know. Okay, we're just going to integrate y dx and just substitute. It's really nothing difficult. As long as you do it quite a few times, it's pretty simple. One thing though that I advise for this kind of questions is that we should always sketch the graph or minimally draw the graph in your GC. Just to be very clear, where are all your axial intercepts? The reason is like this. Let's say, for example, if you're given a graph, for example, and you never sketch. So if you want to find what is the area under this graph, like that, very easy, correct? Like that is very simple because the graph is strictly positive. You're just finding between A to B. But what happens when you're dealing with a case that looks like this? For example, your axis looks like this, and your graph is like that. Oops, okay, maybe I use another color. So maybe you're looking at a graph that's like that, and you're looking for the area of this. Is it correct to actually go from the first point to the last point? No, because this portion down here, this is negative. So if you want to work it out, you should draw the graph first, check where are all your axial intercepts, and then you integrate. That is the biggest advice possible. Okay, do not make the mistake of just integrating without checking the graph. You will GGWP in exam. Okay. Last one, volume. So the volume concepts are actually for the A-level, the H2 math syllabus part is actually very simple. It's nothing too difficult here. It's just memorizing of a formula and knowing how much you're rotating by. So the most of the time, the questions will tell you you're rotated about either the x-axis or the y-axis, and you're given like an angle. So most of the time, you're given like 360 degrees, and you're told that it's rotated one round around the axis. The formula is just as such. Vx is equals to pi, integrating between a to b of y square dx. Just take note that this thing down here, the square is only to the function. It's not to the integral. So if you were to do it like that, this is wrong. Okay, this is rubbish. You cannot do it like that. You must remember that the thing that you are squaring is the function itself, not the whole entire integral. If you do the whole entire integral, you are looking for the area, which is not correct. So just be careful. It's the same analogy here. Okay, it's the same thing for the y-axis. Remember that you're only squaring the x function. You're not squaring the whole entire thing. You will get it wrong during exams. Now, I have some strategies at the bottom here. Same thing, draw. So GC here, you cannot draw volume. You cannot show the rotation, but you can draw a graph. And from the graph, it should be pretty self-explanatory. How does the volume look like? Okay, and we also need to know which rotation are we rotating on. If I'm not wrong, for the A levels, it will be rotating always on the axis. So that one, nothing too difficult to see. Okay. You also need to know where is your starting point and your ending point. Just be a bit careful. Okay, don't make too many mistakes here. I saw the question on the how to integrate the GC. Now later, I come to you now. Okay, so I'm coming to the end. So thank you for those that are still here. So I have just one more chapter. Actually, it's just the DE chapter. There's nothing much there that I want to say. But I'll just quickly go through. After that, then we can wrap up for today already, because I know tomorrow most of you still got school. So we're going to go into DE. Sorry, excuse me. Okay, so this is the DE chapter, which is the very last chapter of the calculus region of the chapter. I would dare to say that DE is actually very, very simple, and it is things that we all have done it before unknowingly when we are doing our standard differentiation stuff. So I will point them out to you when it's an example of something that you've done before when you're actually doing a DE question now. So the main thing about DEs is that every single thing, whenever you form a dy dx equation, or you have a d2y dx squared in your equation, these are called differential equations. And from your differential equations, you will have general solutions and particular solutions. They are different things. So if the question says that we are looking for the general solution or something, remember that we are dealing with arbitrary constants, and we do not need to solve for the constant. And because we are integrating most of the time, remember to plus C or plus D or whatsoever. For particular solutions, this is when you solve. The questions will usually give you a variable, and then you will be able to work out your arbitrary constant. I'll give you a very simple example of a question that we have done before, long time ago. If you remember your O-level syllabus, your kinematics chapter. In the kinematics chapter, if let's say you are given the acceleration equation, and you need to find your velocity, and you need to find your displacement, you need to integrate your equation, right? So you integrate your d2y dx squared equation, you get your dy dx function, and then you plus c, you substitute some variable on the top to solve out for the value of c. Then you reintegrate again to find your displacement, and then you repeat the process. It's literally the same thing. So everyone has been doing this before for a very long time already. This chapter has actually been simplified from when I took the syllabus like a few years ago. So there are different types of DE equations out here. There are three main ones that we need to know how to solve. The first two, which is the dy dx equals to fx, and the d2y dx squared equals to fx. These two, nothing different between them. The only difference is that one is differentiated once, the other is differentiated twice. So if you are going back towards your y, just integrate Integrate once and integrate twice, respectively. Nothing difficult. Most of the time, for general solution questions, they will tell you, find the general solution. Excuse me. If the question asks for particular, then they'll give you the variables to help you calculate your particular solution. Pretty simple stuff. The last one, this one is maybe a little bit harder. So when you're dealing with like dy dx equals to gy, so take note, the main difference between these two functions here is the result. What is it in terms of? For the first two on top is in terms of x. So integrating is very easy. For this one, it's a little bit different because you're with reference to another variable, not x. The way to do it is we are going to use this variable separable method. I don't know do you know this method? Okay, it's very powerful. Basically, what we're going to do is we're just going to divide both sides by the function, and we're going to apply implicit differentiation. By applying your implicit differentiation, applying your implicit, right? Then after that, you integrate, and then you can get your answer. And the reason why we want to do it is we want to force whatever is on the right-hand side to be 1, and we can get it. Okay. So an example of a question is here. So what I will do first is to divide both sides by y squared plus 1. Okay, then we integrate. And we also know that when we integrate dy, I'm missing dx here. Sorry about that. So when we integrate, right, when we integrate, then the dx will cancel off. We're just left with dy, and then that is a very simple integral that we have already learned before. The last concept here, the last concept down there is by substitution. So sometimes, if let's say the DEs are pretty difficult or more big or like a lot more complicated, then the question might ask you to do substitution. And whenever the question will tell you to do substitution. So it will never be a case where you do not know what method to use. Questions will guide you through one most of the time. Okay. Last one was, of course, is also those kind of DE questions that deal with like very big application questions. Those kind you just need to read the questions very carefully. Like all those like what Newton's decay or like the cooling effect, and then you get your differential equation. Those are not difficult stuff. You just need to read the question, and everything is pretty self-explanatory. They will ask you to show the equation or whatnot. Yeah, it's pretty simple stuff. Okay, and that's about it for DE. Okay, so I'm going to stop here. If anyone has any questions, you'll wait first. Right now, what I want to do is the giveaway first. Okay, so for the remaining people that are still here, let's settle that first. Okay, so how this is going to work, let me show my screen. Yeah, so it's basically going to be it's going to be a question. I'm going to show you the question on the screen. It will take a while to solve, of course. So go and try, but I need working okay, to justify that you didn't go online calculator and solve the question. If let's say no one is able to solve, I do have a bonus additional question. If let's say no one can solve that question, then no one gets it wrong. I guess so. Okay, that's how I'm going to do it. I'll show you the requirements first. Okay, so I'll just show you one question. It will be on the screen on the next page. I need you to send your final answer to me in the chat. Let me see. The answer is pretty easy. Sorry, let me find the answer first. Okay, yes, the answer is a pretty easy answer to type out. Oh, no, it's actually not. The answer is a little bit difficult to type out. So if you do have an answer and you tell me you have an answer, I will send you my Telegram and you can forward me your answer. If you get it right, then I give it to you. Okay? So I'll let you guys know also if anyone gets it. And we're going to do like the integration kind of questions. So it's like those kind of like MIT, the integration B. So I found one of the questions there that are pretty cool. Okay, then we'll try that. Okay? I'll give you guys some time to try the question. If it's really too difficult, then we'll move on to the simpler version of the question. Okay, I'll give it a try. 3, 2, 1. Please do not online calculator, because I know you can. Please don't, because I'll ask for working. Okay, if you did that, then of course I won't accept it. Yeah, I drop a hint in case it is too difficult. It's actually not as difficult as it seems. Suggestion is to try expanding. Yeah. Instead of just looking at it as an integral itself, oh, someone got an answer. Can you tell it to me? Yeah, I just sent you my. Oh, wait. Please wait. This is mainly for J1s. So if you're a J2, then later. Okay. Hope you're J1. Okay, can. Wait. Okay, I just sent my tally to everyone. Okay, for those that are still trying the question, just a hint, expand first. Expand all of the certs. It will make your life a lot easier. Okay, if I see the correct answer, then we'll stop. Susanna. Yeah, that's a careless mistake. Yeah, sorry. Yeah, that's a careless mistake. Okay, wait. The YV, one of your terms is wrong, but everything else is correct. I won't tell you which one. Which one? Can you retype again? For YV. And then for the G don't know, ZG. Yeah. Can you send me first? Because I think you came in first. Wait. Oh no, it's wrong. Now you got two terms that are wrong. Yeah. I think some people are making careless mistakes in your integration. So just be careful. Hmm. No. So far, I've not seen a correct answer. Yeah, like whoever is asking me is all not correct. Wait, okay. Wait. I see a correct answer. Hello's people. That person. Yeah, that is correct. Yeah, let me just check. Yes. Oh, okay. Uh, okay, never mind. Retry. Sorry. One more chance for anyone that can get it. Yes. The Hello's people got it right. Eugene, nope, is wrong. Okay, for the people that are slowly sending me, I just read off your tally. The person with the heart shape one, I don't know who you are because there's no name. It's not correct. It's completely wrong. The nano, that one also not correct. That one only one term is correct. Everything else is wrong. Okay, we'll try until 9:45. Okay, if no one can give me the correct answer, then I'll give it to the Hello's people. Okay. Oh, okay, wait. I got answers. Uh, okay. Okay, wait. Can stop already. I got someone. This person, I don't know who is it. Kivlyn. If I don't know how to pronounce your name. Yeah. It's correct. Very good. Yep, it's correct. Okay, so I think you do you know who you okay, whoever you are. I hope you're a J1. Are you a J1? Okay. Are you J1? Please tell me you're a J1. Oh my god, if you're not J1, then please don't lie to me. I'm very poor thing. Are you J1? Oh no! The person is not J1. Okay. Sorry, I need it to be a J1. Thank you for being honest though. But it's correct, it's correct. The Nicole. No, it's wrong. Okay, 2 more minutes, we try. Okay, if really cannot, then I give it to the sorry. Oh, okay, got another answer. Go, send. Susanna, is it? Very close though. I think like one term is wrong. Yeah. Mhm. No, it's wrong. No, sorry. Whoever just sent it to me. The Josephine, right? No, it's wrong. Yeah. Okay, I think most people are stumbling at your simplification of your certs. Uh, Looking at it, right, I think some people, you should simplify your search properly. Yeah. I think maybe it's your indices law. you need to remember that a to the power is an O-level thing again. Oh, sorry. A to the power of m times b to the power of m. Wait, what am I saying? Should times a to the power of n, a to the power of m plus n. This is the main mistake that most people are making. No, you're still wrong. the one with the heart shape one. No, it's not correct. I'm so sorry. Wait, Eugene. It's correct. But where's my plus C? okay lah. Are you year one? Or the giveaway is for notes. Yeah, it's for a copy of the curator notes. Yeah. Oh my god, why is only everyone that's getting it right only G2? Oh, no. For Susanna, no. One more term is wrong. Now it's like more or less there already. YV. I thought I said just now already. No, it's wrong. The VY one is also wrong. No. Okay, I think this is too long. Give it to the hellos people. Like, whoever you are, if you are still there, okay, I will stop here, huh? Or do you guys want another chance? Okay. I give some. Okay. One last minute. Anyone can give me the correct answer. I give it to you. It must be year one. I'm so sorry for. Send. Wait. Okay. We wait 1 more minute. Okay, give one last person 1 more try. Okay, if it's correct, then I give it to you. No, it's wrong. It's still wrong. I'm so sorry. Okay. Yeah. So I give it to the. Must be the wait again. Okay, faster. Cepat. Okay. Wait, must be J1, huh? Must be J1, huh? Okay, I will just release the answer later. This one you set for O-level students better to test their indices. Nah. No. You're missing something now. Are you the Eugene that I know? The Eugene from that group? Is it the same Eugene? Oh, okay. Hello. Okay, I think we stop because I don't think anyone's gonna get it anytime soon. Okay, anyways, yeah, the hellos people, can you send me your address? I send it to you. Okay. Thank you for trying. I'll give you the answer. So for those that are trying, thank you very much for participating though. It's pretty heartening to see so many people participating. Okay, but for those that got it right, thank you very much for trying. I'll give you the answer. This is basically just testing a lot of indices laws. Okay, it's 8/15 x to the power of 15/4 plus 1/3 x to the power of 3 plus 8/7 x to the power of 7/4 plus x plus c. This answer. Okay. Yeah, so whoever just sent it to me. Yeah, the Shun. Yeah, it's too late though. I'm so sorry. Oh, the answer is too pixelated. Sorry. Yeah. 8/15 x to the power of. Oh, okay. Yeah, thanks. 8/15 x to the power of 15/4 plus 1/3 x to the power of 3 plus 8/7 x to the power of 7/4 plus x plus c. Let's answer. So for those that got it wrong, it's most likely all is indices log above. Okay, you go and check your own working. It's most likely you messed up somewhere in between. Okay, so just be careful. Okay, so no more chances. Okay, I'm sorry. Okay, but hope everyone had fun with this. I think we should do more of this. I always wanted to hold like an integration, like little thing as well for students. They can be like prizes. I think it'll be quite fun. We shall see in the future. Okay, so before we end, okay, I know it's pretty late. So I just want to say a few more things, then we can end off for today. Okay, if anyone got any questions, can just ask me as well. I will drop the answers inside the Dropbox, that link. So in my notes, right, you see a little link, the QR code. I'll drop the materials there. Okay, I'll drop the solution there as well. So I'll type it out and send it to you guys. Okay. So this was actually the other question that I wanted to try. It's pretty simple. The answer is -half, I think. Pretty doable. Okay, so I just want to say a few more things and then we can end off for today. Okay, so first and foremost, I'd just like to give everyone a quote of mine. So this is something that I said to my O-level students, and I think it's very, very applicable to everyone else that is taking your national exam soon or taking your promos. Okay, is that even though you understand everything, you may not be able to apply your concepts. So please remember to practice. Currently, I'm a uni student. I still have to practice my math. Also, when I go for exams, also for GGR. Okay, so that's very important. Now, some revision tips. This is more for for everyone. Okay, especially for those that are going for exams very soon. Please go and practice as much as possible. Okay, practice, 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 practice. Clarify your doubts as much as possible. So now, because I hope that more people will know that I'm taking over the A-level math side. Okay, anyone has any questions with regards to H2 math or any of the other maths in general, you can just message me. I will always reply. Okay, so my tally is out to anyone that anytime wants to just get a reply, you can just let me know. Okay. Last thing is consistency is key. So I know we in JC we don't have a lot of subjects, so it's good that we focus and we practice as much as we can. Okay, for me when I did my JC math, I always do like 1 to 2 hours worth of math almost every single day. So my combi in JC was PCME. So I did 12 physics, 12 chem, 12 math, and then maybe 1.5 hours of econs because I hated econs. So but for me, I really, really love math a lot. So I spend more time on math lah. So I hope for me, like my purpose in life is to make people love math. It's very sad to see people not like math because math is such a beautiful subject. Okay, I really do hope that people can see it. From my point of view, it's really, really a beautiful subject. Okay, well, I just want to talk about this as well. So group tuition. So I'm here to actually just advertise a little bit about my upcoming classes. So for my next year intake, as I mentioned at the very start of the session, is that I will be teaching JC math as well, other than O-level math. So I'm looking for students if possible. So some things that I just want to stress, okay, is this trial package here and this early bird package here. So from today onwards until the 16th of October, if you feel that you like my teaching and you enjoy whatever I've done, you want more resources from me, you can try on this early bird package where what we will do is that I will be giving you 2 sets of the notes for free, any of the JC subjects that we have. You get to choose your class slots priority, and you will get this promo exam kit. So let me share with you what this is. So exam kit is basically another set of notes. So whatever you receive today, this is actually your revision package. This is the free version that is out in the wild. There's actually another version which I have, which is this. So this is actually an exam kit that contains every single topic in the whole J1 syllabus. It's also notes. So you can see starting from functions all the way down to complex numbers. So this is something that I worked pretty hard for. And whoever wants to sign up with me for this early bird thing, you actually get a copy of this for free. And I will PM it to you whenever you sign up. So it's between now till the 16th of October. So you got about 2 to 3 weeks to think about it. Okay, it's pretty much a lot of notes and questions. I can just scroll very, very quickly. Yeah, it's basically what I will be providing for you. Okay. Now, let's move on to this. So, resources. So this is also to just share what is my teaching philosophy for some of my students as well. So I do this for my own O-level students. I do this for my own whoever students I have. So lecture notes, I create my own lecture notes. So whatever you see here in like the revision package or this like exam kits, they're actually for my own personal lecture notes that I write on my own. So if you like this style and you feel that it's not bad, maybe you can consider. Okay, every single topic will have one, including tutorials, including questions and everything. Homework. So for me, I have quite a lot of resources, especially for O-levels and JC. JC, I have resources starting from 2010, if I remember correctly, all the way till now. Been storing like O-level papers with like questions and everything. So I keep like a database of questions that I feel that are pretty good. So whenever students go for exams, I just send them this database to practice with solutions provided, of course. And for me, I craft my own homework every week. So if you come to me for classes, I will give you a set of homework. And this homework will have like 5 to 6 different questions, multiple topics all week. And you'll get to practice every single week. Class assessments. So for me, what I like to do is I like to give students time to do things on the spot. So every ending 15 minutes of the lesson, I like to actually give students 1 to 2 questions, maybe just 1 question for A-levels. Then for you to do on the spot, then I can bring back and actually grade to see whether how are you doing for that particular topic. Class test. So this is something that I do. I do like bi-monthly now. So every 2 months, every 3 months, I'll hold like one small test to test whether do you actually know your stuff that you're learning in school and also learning from me. Solutions. So this is something that I pride upon as compared to other people, is that for me, I write all of my solutions from scratch. So if you want, okay, because as I just took over A-levels, I don't have anything right now that I can show, but if you go over to see my O-level stuff, those are the quality that you will get. So all of the O-level solutions, you will get it in the A-level form. So I will type out every single thing that you need. You can actually just self-study from the solutions itself. Yeah. Last thing is just additional resources that I provide. So for example, like curated notes, I'll give you the curated notes that I will be writing, exam papers, tests, quiz. I'll go through, sorry, that's A-levels. I'll go through the A-level papers and everything to get you prepared for your exams. Okay, that's basically it from me. So if anyone has any questions, you can feel free to ask after I finish. Okay, and also the link to sign up for any trial lesson, or let's say you are interested to work with me for your A-levels, then you can feel free to sign up as well. Okay, with that, I really do hope that you guys learned something from me. You had fun. I hope I didn't bore anyone. Okay, and yeah, apologies again if I coughed and I didn't speak very coherently today because of my voice. Okay, I hope that everyone learned something from me today. Okay, with that, thank you very much. See you guys soon if I were to hold any free sessions in the future. Bye-bye.